To give you a background, you may hear it or tell you here I'm working now for the work group, but this project thing is from the time at the TU Dresden, so I'm trying to make my PhD. My defense will be in some weeks. So I'm now working also in QGIS and PostGIS and all these things. So keep in background, that's things I tried to collect while I was teaching, helping at the university, and just a short introduction why all these things. So cartography. The output of cartography is a map. It's not just about drawing lines somewhere, taking colors. It's making from like aerial images, building objects, and building a model. And this model depends always on a scale. Scale is the most important thing on a map. And you have to go from one scale to another. You have to remove things. And that's generalization. You have to remove things in a good way, that the important things stay. What are the classical definitions that you hear and find in German textbooks? And I will roughly keep around this, what I've learned. So my structure overall, short introduction, what is generalization? Then now I will come to the more general problem with generalization and OpenStreetMap. Some examples and solutions which I found, maybe where you can take a look. If you need some help, some ideas, and overall an outlook, and maybe at the end you will understand why I'm holding this presentation. Oh, nice if you try to export some things and it doesn't work. So overall, I will go to this. Oh, yeah, awesome. So generalization, there are three things. I will try to explain it here. You're trying to create objects from real-world things. Usually you should see here something like an aerial image. I don't know why it's now missing in the PDF, but you have a building, you have a water feature, and you're sketching all of it. You create objects. If you're working with OpenStreetMap, you import all these things in a PostgreSQL database and make it a new model. You have to convert this from the OSM data model into a OGR compatible data model, and you do some cleaning. That's something like a model generalization. At the end, you should see, if I have time, I'll draw it also later here, there's a cartographic generalization. When you say, okay, you're moving objects far away from another, that you can clearly read it out. If you have more general things, where some kind of operators that describe what happens there. It's not algorithms, it's operators. You can say you can simplify a line. Simplify a line is maybe implemented by Douglas-Polka algorithm, by Wis-Wallingham, Wyatt. You can smooth something, like a child smoothing you can use for this. There are many more. I just cut something out to give you the idea. There are many more things that can happen than just applying a Douglas-Polka or Wis-Wallingham algorithm and say, okay, I've done simplification, I have done generalization. So, if you're classical looking what happens here, you're looking what happens with cartographic maps. You have a defined set of scales, 10,000, 25,000, 50,000, 100,000, and so on. This whole job of generalization is mostly done by national mapping agencies, and they use quite complex software. It's not usually about Esri. Esri tried to earn money with this, but there are other companies like Axis Software, Spatial One, who are more into this topic and were more widely used in the past. But if you go now to OpenStreetMap, you say, okay, what's this OpenStreetMap? You have something similar like the set of scales, you have zoom levels. It has a fixed software that is usually in use, PostgreSQL, but we may have to use for generalization. You have some minimal dimensions. In classical, there are millimeters. If you go to web, you have just pixels. But you have the same goal, removing things, simplifying things. If you want to have a good look what's happening here, there's a nice, sadly just German publication from the Schweizer Gesellschaft für Kartografie. Try to get it. On the web, you can get it for €5. Otherwise, just write an email. I have the PDF, and I had said nothing. So, that is not a blank field. If you are looking about cartography and generalization and OpenStreetMap, you can look into many objects, not objects, projects. I don't want to mention here OSM Carto. I know there's many things inside. You can also find some nice features for generalization, but I may want to talk about the projects which are less known. We have maybe the OpenTopo map. This has a nice procedure developed for selecting the most important peaks for a scale. We use the topographic isolation. We have a nice algorithm implemented about curved labels. You can also look at the map tiles. We have another approach copied from Mapbox, like the label grid, which you see the most important places in the grid cell and say, okay, here's the most important places. It can be maybe a city, or it can be even a small town in a rural area. We have to merge nearby polygons and small polygons to create more efficient vector tiles. It's also simplifications. The OpenMap LT is a very nice example of what's possible with generalization and OpenStreetMap. We have a great algorithm for simplifying buildings. I've put here screenshots. It's look very clear for me. If I would put OSM Carto there, it wouldn't look so nice. We have also something like merging parallel road lines, implemented also with PostgreSQL. So, there are things that already happened. So I've done a bit my PhD, I have done a bit teaching to students who have to explain, okay, you have heard in the professor's lecture, we have to do cartographic generalization here. Let's try to explain. The first one is now from my research. I had the question how to select important points like peaks. You see here, I come from Dresden, it's the Saxon Switzerland. There are many peaks. Which one is the important? Or maybe if you look on the settlements between Berlin and Dresden, it's about 200 kilometers. If you look to OSM Carto, no city is shown at the scale in between, but there must be something in between. How to fix this in general? The abstract problem, you have points, many points. I have here always an example. And you have a numerical attribute like population. Okay? There we go. There was the label grid approach. I found it at first at Mapbox. Maybe it was already earlier known somewhere. I don't know. I just have this implementation found from Mapbox. We take a grid and we show inside the grid the point or the city with the highest population. You see here the grid and you will see, okay, in each grid cell is 1 point. So you can make a better selection than just saying, okay, I want to have the cities with more than 1 million inhabitants. Then you would only see Praha and Berlin. Another solution which I found is something like called functional distance approach. It's more like a modeling approach. You model something like these curves. The height of the curves is defined by the population. And then you have a smoothing function going out, and so you get maybe, according to the function's parameters, more nearby cities or less nearby cities. Another solution. My own idea was to take the approach of the topographic isolation and not use the always like a digital elevation model. I say I just look for the next point. So do this something in discrete and not on a continuous model. And when you have always this search radius and you say, okay, in the circle of X kilometers, where are the most important city which I want to show? Then you get this solution. If you're interested in this specific problem, you can look there. I've written a paper of it. It's linked there. You can get the slides, Google it. There's a Postgres implementation of the discrete isolation. I've written a QGIS plugin. So play around and let's make better maps about this. It's also now implemented in a new backend for the OSM to PGSQL with some generalization, if you want to try this out. Not this one, this one. Maybe here a comparison. I made a web map for a project, and you see here on the right side my map, which I created with the discrete isolation. And on the other side, OSM Carto, where you can see the difference. There are many more small towns shown, which are in between the big cities to give you a better overview. So, another thing which I was also thinking about is the simplification of features like forest polygons or building polygons. What was more for teaching the students how to apply algorithms and to combine things. So, if you're looking on the original and in the upper left, and we say, okay, I want to simplify, just throwing a Douglas polka on it doesn't work. But if you're going more into detail, and you learned also, if you're learning cartography, a bit photogrammetry, you have this like opening and closing. That is, you shrink and expand features. You can do this also with a negative buffer, with a positive buffer. And you see here, in the end, looks for me a bit more nicer and more generalized, like just applying a Douglas polka. You can also apply a Douglas polka or this Wallingham at the end to remove some points. For me as cartographer, this looks a bit better. It's always a bit subtle what is better or not. I have shown this here on a bigger area. You can see here with the outline, the generalized version, and just in the green area, the original OpenStreetMap data. If you want to try this out by yourself, there's also the SQL code to do this, where it's also explained how it can work. So I just expand the features, I cluster it to merge nearby features. I merge these features according to the clusters, because sometimes you have to split these polygons in some points. You see here, I grow over the small gaps, and then I'm merging this. Simplifying the buffer, multi-polygon to single polygon to have an area selection. I'm throwing out holes. There are many things in between if you're simplifying features and not just saying, okay, I do this with a Douglas polka. But be aware, it's not perfect. Maybe there are some edges where I say, okay, I'm not happy with the solution my algorithm or my idea works like, but maybe, yeah, it's a 90% solution and not perfect one. So, another problem is if you're going to area features like buildings which have rectangles. Someone give me this hint, just try a buffer, but say, okay, the important thing you have to do is with the end cap flat and the joint Prizren. And then if you see the Douglas polka with Wallingham, it's not so good. But if you're doing this with maybe you should leave the door open, with a buffer, it keeps more the general shape of the building and is not just simplified. So, I've done this to a little city next to Dresden where I can go. I've done also some clustering overall to merge these features, and this can be the result, how it looks. Where I say, okay, I have removed all the small buildings, building bigger polygons. Would be also interesting for vector tiles if you can say, okay, I have compromised this, having less points would be advantage. Just a short insight, what's happened here. So clustering the touching buildings instead. I'm merging them. I made a simplification with this buffering. Then I go back to the buildings and should look which I have lost. Maybe there are some buildings which are a bit too small, or have maybe a house number where I say, okay, we are according because they are a church or something. This, when I say, okay, I make you to a point, give you a rotation according to your main axis, and then I have an abstract building just as a rectangle. It's somewhere called typeification in cartography. And then I add the buildings again. So maybe some buildings like this here, or maybe this here, are just now typified, shown by a general rectangle. The buffer solution is nice. You need no other software, but sometimes it gives you some hard edges like this one here, where I say, okay, that's not so great, but It's just the 90% solution. So I have give you some rough insight why I'm trying to do this here. I'm putting, like in the introduction today, I'm putting some seed to push this topic about cartography, because generalization is an important topic in cartography, where many people say, okay, it's done, now let's proceed with AI. I think we don't need the AI, we have to just collect knowledge. I'm trying to share my knowledge, it's just a little bit of this complex topic, and to push this a bit. I'm trying to build a general implementation that you can have just OSM data, and at the end I will have a map at the scale 1 to 25,000 QGIS. I started this, I have to open seedmap import, I have my algorithmic for generalization, I have to merge this. If you're happy, you can use this, I will try to work on it. You can use my discrete isolation, you can also try with the point selection algorithm. But my background messages talk to me. If I would be happy if some other people have said, oh, I found a solution, let's share it. Like I share my ideas that we can make better maps. So my idea is later to build something like a collection of generalization solutions, not looking everywhere in a project to find a solution and then say, okay, maybe I can use this, I have to re-implement this, I have to adapt this. It would be nice to sum up the knowledge somewhere where you can find it and easily access. So, that's it. Thank you.